Okay, now members, welcome. We are going to see some proofs here, but this is the topic under trig. So please don't forget to subscribe to the channel. This is the proof we are going to be having. It says, prove that root of 1 minus sine over 1 plus sine is equaling to sec x minus tan x. Now the hint we are going to use the difference of two squares like that, and also we are going to use the first identity, which says cos squared plus sine squared is equaling to 1. So if you make cos squared the subject, this is what you do get. Now I'm going to call this the left hand side and I'm going to call this the right hand side. So what we are going to do, we are going to make sure that we prove that the left hand side is equaling to the right hand side, as you are going to see. Now if I start with this one is called my left hand side. So I want to show that it's equaling to the right hand side, which is this, of course. What I'm going to start with, I'm going to start by, you see that what we have here, we have sec, we have cos. When you see all these two, they are reciprocals or they are identities. So this is 1 over cos, this is 1 over, this is sine over cos. So all of them are having cos. So now my idea is to try to get a cos down. How am I going to get a cos down? Is by first creating the difference of two squares by multiplying this same thing up and down. So to start with, now I'm going to multiply this up and down. So if I have this down, I'm going to have 1 minus sine x, the same thing up and then down 1 minus sine x in that order. So when you look at these two, you see that I've done nothing, because these ones we can always remove them, because this one we can cancel this and then we come back there. So when you look at this now, this and this, they are the same, so it's now going to be one bracket, they're all squared. But when you look at this and this, it's going to be a difference of two squares when you come to this part, as you can see. So if you have the first term and the second term, they are the same. The only difference is this is a positive, this is a minus, then you can every write them as that. So from there now, I can write this as, this will be equaling to the square root of, now these are 2, so it's the same as 1 minus sine, the whole squared, over, here I can apply a difference of two squares, which is 1 squared minus sine squared x, applying a difference of two squares, this concept there. Now, you know that this one is going to be now 1 squared is the same as 1 minus sine squared. But we know that from the first identity, 1 minus sine squared is cos squared. So now, there I will be having this as the square root of, now I have this as 1 minus sine x, the whole squared, over 1 minus sine squared, the whole of that one is giving us cos squared x. And we have a root of this and this. This one will result into 1 minus sine x. This root goes with that square, and also this goes with that square. The whole over the cos x. This is the cos I wanted to create, and so that I don't have any root on it. So we can separate. This is 1 divided by cos. We get sec x minus sine over cos. We get a tan x, and so we have proved that the left hand side is equaling to the right hand side, and the proof is that simple. So to get more topics, to get more proofs about trig, you can visit the playlist for more. That's it. I wish you well.